So this is 109, Graphing Quadratics, Guided Practice. We're going to start doing number 2 together. So your first step is to look at the A value. What does the A value of 3 tell you about the graph? It tells you 2 things. It's stretched, and what else? Is it going to be concave up or down? So concave up. You don't have to write that down for yourself, but I just start thinking that when I start a problem. So now, how do I find the vertex in standard form? Does someone know the equation to find the vertex in standard form? Magic formula for finding the vertex in standard form. So you do -6 divided by 2 times A, so 2 times 3 is 6. That tells you that your vertex is at -1 comma something. How do you find the y value? What do I do with the x value? Plug it in. So we're going to take the -1 and plug it into this equation. So I'm going to get 3 times just 1, right? Because -1 squared is 1. So I'm going to get 3 minus 6 minus 3. Looks like -6. So I did all that work just to find the vertex. That's why I like vertex form better, because this takes a lot of time. So -1, -6. 1, 2, 3, 4, 5, 6. There's my vertex. And I know that I'm stretched and I'm concave up. So I think of the parent points, 1, 1, 2, 4, 3, 9. I'm going to stretch those. So instead of 1, 1, I'm going to do 1, 3. Over 1 from the vertex and up 1, 2, 3. I just hit the y-intercept. The y-intercept is -3. The c value should confirm that the y-intercept is at -3, and it does. So I'm going the right direction. And then normally I would go over 2, up 4, but I need to stretch the 4 3 times as tall. So I'm going to go over 2 and up 12 for my other point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you can do a symmetrical point on the other side. So there it is. Do you want to do one more in standard form, or do you think, yes, one more in standard form? I'm going to jump and do number 3 then on this one. Here's number 3, and then that'll leave you 1 and 4 to try on your own in a couple minutes. Okay, so number 3, I look at my A value. Oh, for people who weren't here, or just as a reminder, it always has to be in standard form before you start. So if I have an equation written like 7 plus 4x squared minus 8x, you want to rearrange it for yourself, 4x squared minus 8x plus 7, before you start the problem. I just happened to put all of these in standard form. So what's the -2 tell you about this equation? 2 things. It's what? Yep, it's being stretched by 2, and it's going to be concave down. So those are my 2 pieces of information from the A value. And then I'm going to calculate -b over 2a and see what I get for x. So what do I get? -b, so I'm going to get -4 over, and then 2 times -2 is also -4, isn't it? So this time I get +1 as my vertex. I'm going to usually make it come out as a nice integer for you that'll fit on your graph. So a fraction might be a red flag that something is wrong for sketching a graph. All right, plug in 1, see what you get. See if you can do the correct order of operations. So did you get -2 plus 5 is +3? Does that sound like what anyone got? So I know that I did it right? Okay, you tried it. Right, because this gives you -2, and then you're adding 4, adding 1. So 1, 3. There's my vertex. And I know that I'm concave down with a stretch of 2. So over 1, down 2, and that actually allows me to check my y-intercept. Hey, my y-intercept is 1, and my c value is verifying 1, so that's good. And then if it's usually 1, 1, 2, 4, I'm going to go over 2 and down how much? 8, because I'm stretching the 4 twice as steep. So over 2, down 1, 2, 3, 4, 5, 6, 7, 8 as steep. So you always want to think about your parent function, 1, 1, 2, 4, 3, 9 from the vertex, because that's how you're going to stretch it or shrink it on number 4. Okay, so in a few minutes, you're going to go back and try 1 and 4 on your own. Can I skip ahead to one of the vertex form practices? Let's see, which one should I pick? We can just pick number 5, right? They're all about the same. This is going to review your transformation rules for those of you who might want to redo that quiz. So I'm asking you some questions down here. Do you go left or right and how much? Up or down and how much? So what would you say? Right by 3, that's what the x minus 3 does. And up 5 is what that plus 5 does. So to record my vertex, it's +3, +5, because it was right and up. AOS stands for where is that axis of symmetry? So if you plot your vertex at 3, 5, an axis of symmetry is a vertical line that goes through the vertex. So we record it as the vertical line x equals 3. AOS, you might hear LOS, line of symmetry, AOS, axis of symmetry. It's just that vertical line that cuts it in half, helps you graph a parabola. So then, what's my A value in this problem? Right, when nothing's written in front of the parabola, it's +1. So this is just the parent function, concave up, hasn't been stretched or anything. So just 1, 1, and then over 2 up 1, 2, 3, 4 is all you can fit for this parabola. Smooth curve connecting the dots. Arrows are nice to show that it goes forever. What would be the range of this parabola if you had to write its range? Domain is all real numbers. What's its range? Y has to be what? Greater than or equal to 5, right? Y starts here and then goes only up. So the range would be y is greater than or equal to 5, just to keep that vocabulary word in your head. Okay, you can do 6, 7, and 8. Those should be pretty quick because you can literally read the vertex right in the equation. Let's just review how to do one in intercept form. Let's pick the half one. So how about 10 right here? All right, intercept form. So look at the difference between what they look like. So standard form, ax squared bxc. Vertex form always has this being squared. And then intercept form has 2 different parentheses. So the 2 different parentheses, I said I was going to do the half one, right? Okay, they tell you the x-intercepts. That's why it's called intercept form. So the x-intercepts on the graph using the zero product property. So one of my x-intercepts is at -4 from this first parenthesis. If I plug in -4, I get 0 for my x-intercept. The other one is at +4. If I plug in 4, I get 0. So -4 and +4 are my 2 x-intercepts. You plot those first. Then you have to find your vertex. Your vertex is located on the line of symmetry, so that's halfway between your 2 x-intercepts. So in this case, x has to be 0. That's halfway in between. How do I find my y value if I have an x value? What? Oh. Let's see, I get 1/2 times +4 times -4. Isn't that -8? I could tell because I know it has to be concave up. So I know my vertex has to be below my x-intercepts to be concave up. So if I was going to flesh this graph out, think about 1, 1, 2, 4, 3, 9. You're cutting all your y values in half this time. So 1, 1 becomes 1 comma a half. 2, 4 becomes 2, 2, half as steep. And 3, 9 would be 3, 4 and a half. 1, 2, 3, 4 and a half. And then we get to our x-intercepts. And it would be 4, 16, and it's 4, 8 instead. Because 4 squared is 16, so half as tall. I went over 4, up 8, and there's my x-intercepts. Do you need another intercept form one together, or are you feeling like you can conquer the rest of this guided practice? Yay? All right, so we've got till 10:20. I'm going to give you about 10 minutes, and then I'm going to see if I can jump into